We recently developed a conductive silver ink for use in commercial rollerball pens. We're using these pens to directly draw circuits on flexible substrates, like paper. The lines it produces are about 1 millimeter wide, so it is highly compatible with surface mount or through-hole components, like resistors, transistors, and LEDs. A portable battery can supply enough power to operate one of these devices. The ink is composed of silver microparticles, water, and a cellulose binder. During writing, the silver particles form a conductive network on the top surface of the paper. As the solvent dries, the pattern becomes gradually less resistive, and when this pattern is completely dry, its resistance is only 20 ohms. Unlike commercial conductive ink dispensers, our custom silver ink pen does not need to be shaken or squeezed. Our ink also dries faster, and our pen is more conducive to natural handwriting. To fabricate the conductive silver ink, you need to use common solvents, a metal precursor, a polymer capping agent, cellulose binder, and a reducing agent. You'll also need laboratory glassware, stir plates, a centrifuge, a homogenizing mixer, a heated sonic bath, and syringe filtering supplies. First, we disperse an aqueous solution of silver nitrate into a flask of water, polyacrylic acid, and diethanolamine. The silver nitrate quickly dissolves, and over a period of 20 hours, the particles grow to a diameter of 5 nanometers. We place the flask in a heated sonic bath, and the particles ripen to an average diameter of 400 nanometers. After cooling, we transfer the solution to a larger flask and scrape out the thick precipitate. Next, we add ethanol, which coagulates the particles. We then pour off most of the supernatant and centrifuge the remaining liquid. After centrifugation, the compacted particles can be redispersed in water. The dispersed particles are then forced through a syringe filter in order to remove hard agglomerates. We then add a cellulose binder into the filtered solution in order to control the ink rheology. Next, the mixture is homogenized. Before we can put this ink into a pen, though, the solvents are allowed to evaporate until the ink has the desired viscosity. After dismantling a commercial rollerball pen and washing out the original ink, we can fill the reservoir with our custom silver ink using a flat-tipped spatula. We then replace the rollerball tip, and a couple blasts of compressed air force the ink into the tip. We slip on the outer cover, and now we're ready to write. I'm Annalisa Russo, and I work in Jennifer Lewis's group at UIUC.